In this video, we are going to discuss about universal gates. Universal gate means it can able to implement any arbitrary functions. And it can implement any gates with the help of these two universal gates. So there are two types of universal gate. One is NAND and NOR. So you know the symbol for NAND gate, right? This is how the NAND gate look like. So this is a NAND gate, and this is how the NOR gate. Okay, so this is a two input NOR gate. So with the help of these two gates, I can, or with the help of NAND gate, I can implement any function, or with the help of NOR gate, I can implement any functions. So if I want to um, convert, if I want to implement, okay, if I want to implement AND gate using NAND gate means how it is possible. So you know that this is my um, NAND gate, right? So if I implement A dot P, A and B, if I give the input as A and B, I will get A dot B the whole bar, right? So here I have to insert one um, inverter. So how to convert this NAND gate to an inverter means like this. If I connect, uh, if I short the both the inputs, I will get A dot B. So this is how I can implement. You can see A dot B into a whole bar into A dot B the whole bar, right? So this is A dot B the whole bar. This is also A dot B the whole bar. So if I do this one, since both the values are same, I can write like this, right? A dot B the double bar. That is something but AB. So suppose if I want to implement the okay, OR gate using NAND gate. Okay. So you know how the OR gate look like, right? This is my OR gate. So and the NAND gate look like this, right? This is nothing but a NAND gate. This is similar to if I apply De Morgan's law, right? If I apply De Morgan's law, I will get this one, right? Both are same, right? These two are same. Okay, A bar plus B bar, right? So I have to add two more inverter at the front of the at the input side, right? So if I add two more inverter like this, okay, here the bubble represent the NOT gate, so the inverter, right? So if I add like this, so this is also a OR gate, right? So this is A B, this is also A B, so I will get A plus B, right? So here now I am going to convert this one into a, I can convert this one into a NAND gate because this is similar to that of this one. And for NOT gate, I can construct like this. Okay. So I'm going to redraw it like this. So this is nothing but A plus B. So you can see this is A bar and this is B bar, right? So if I multiply, I will get, so what is A bar dot B bar the whole bar? This is equal to A plus B, right? So again, if I want to implement XOR gate. Okay, XOR gate using an AND gate. So for that one, can connect like this. So this is A, B. Okay, this is nothing but A dot B the whole bar, and this is nothing but A dot A B the whole bar. Okay, this is B dot A B the whole bar. Right. So this I can write it as A plus AB. Right. This is nothing but B A bar plus AB. Right. This is nothing but B bar plus AB. So if I do like this, I'll get write it as A bar plus AB, right? And the second write it as B bar plus AB. So if I multiply these two things, right? And if I take the whole part, right? So this I can even minimize it as A bar plus C into A bar plus B, right? The second it as B bar plus B into B bar plus A. So this is equal, this is 1, right? 1 into A bar plus B, and this is the B bar plus A. So instead of writing like this, I can write it as A bar plus B bar plus AB, right? So this is equal to A bar plus B the whole bar plus B bar plus A, sorry, B bar plus A plus A the whole bar. So this again I can filter it as A B bar into, sorry, plus B A bar. So this is nothing but A XOR B. So this is how you have to implement A XOR B. So suppose if I want to implement XNOR gate, okay, XNOR gate using NAND gate means, so if you add one more inverter to this one, right, like this, it becomes XNOR gate, right? And if you want to implement NOR gate, okay, if I want to implement NOR gate using a NAND gate means, you know how the NOR gate look like, right? So this is your NOR gate. So I want to add two more inverters to this one, right? So if I add two more inverters like this, okay, A B, there is nothing but A plus B the whole bar. So A B, so you'll get A B, right? And this one I can draw it like this, right? This inverter I can draw it like this. So there is nothing but A plus B the whole part. So I can draw. So instead of this, I can draw it as a NAND gate, right? So you can see this is nothing but A bar B bar, right? So this is nothing but A bar B bar the pole bar. Okay, so if I take the inverse of this one, this becomes A bar, B bar, right? Both are same. So likewise, you can do it for NOT gate also. Okay. Even you can implement any gate with the help of NOR gate. Okay. Since the NOR gate also is called as a universal gate. Suppose they are asked to implement A, B plus C using NOR gate. Okay. So how to implement this? First, you have to draw the this one. Okay, so this is something but AB and this is C. So y is equal to AB plus C. Okay, so I'm going to convert this one into a NOR gate. So in order to convert this one into a NOR gate, so you have to add two more inverter to the input of the AND gate. Okay, so if you add two inverters at the input of the AND gate, it becomes a NOR gate. Okay, again you can see the bubble should be at the output of the OR gate. So I am going to add two inverters at the output of the OR gate. Okay, so here also the same. See, this is AB, so you will get AB. This is C, so you will get the output as AB plus C. So in this one, I can replace this whole term into a NOR gate, and this is also a NOR gate, right? So I can draw like this, right? So for to implement NOR gate, I can draw it like this, right? So this is a NOR gate. You got it. Yes. So here I can convert this one to a, this is something but pure NOR gate, right? For this part. Okay. Again, this is another NOR gate, right? This is another NOR gate. And for inverter, you have to draw it like this, right? So this is your y is equal to AB plus C. So you can verify it. This is A bar, B bar, and this is nothing but A bar plus B bar, the whole bar, right? This is C. So this is nothing but A dot B, right? A dot B. So this is nothing but AB plus C, the whole bar. So this is equal to AB plus. So this is how we have to implement.